Beneath the frozen surface of Europa, there is an ocean. Not a small one, not shallow, not temporary. An ocean so vast, it may contain more water than all of Earth's oceans combined. And it has never seen sunlight. Not once. No sunrise, no sky, no horizon. Just endless darkness, stretching for hundreds of kilometers in every direction. And yet, scientists believe something could be alive down there. Something moving, in the dark. For centuries, Europa was nothing more than a distant prick of light in the night sky. It was first observed in 1610 by Galileo Galilei, alongside 3 other large moons orbiting Jupiter. At the time, it changed everything. It proved that not everything revolved around Earth. But Europa itself remained a mystery. Even through powerful telescopes, it revealed almost nothing. No mountains, no deep shadows, no obvious features. Just a smooth, bright sphere. Almost too perfect. That smoothness turned out to be the first clue. Because in space, nothing stays perfect for long. Asteroids and comets are constantly crashing into moons and planets, leaving behind craters that last for billions of years. The older a surface is, the more scars it carries. But Europa has very few craters, which means its surface is young. And if a surface is young, something must be constantly renewing it. Something powerful enough to erase billions of years of history. As spacecraft began exploring the outer solar system, that mystery deepened. When the Galileo spacecraft arrived at Jupiter in the 1990s, it finally gave us a closer look at Europa. What it found was unlike anything scientists expected. The surface was not just smooth, it was fractured. Endless networks of cracks and hutots stretched across the ice, some running for thousands of kilometers. In many places, the ice appeared broken into large plates that had shifted, rotated, and refrozen. It looked less like a solid world and more like something floating, like ice drifting on water. That observation changed everything, because it suggested that beneath Europa's icy crust, there was something else. A global ocean, hidden below tens of kilometers of ice. At first, it sounded almost impossible. Europa is incredibly far from the sun. At that distance, sunlight is weak. Surface temperatures average around minus 160 degrees Celsius. Cold enough to freeze almost anything solid. So how could liquid water exist at all? The answer lies in a force we rarely think about. Gravity. But not just gravity pulling things down. This is tidal gravity. Europa does not orbit Jupiter in a perfect circle. Its path is slightly elliptical, stretched by the immense gravitational pull of Jupiter and influenced by nearby moons like Io and Ganymede. As Europa moves closer to Jupiter, the planet's gravity pulls harder. As it moves farther away, the pull weakens. The result is constant flexing. The entire moon is being stretched and squeezed over and over again, with every orbit. This continuous motion generates heat inside Europa. Frictional heat. The kind of heat you feel when you rub your hands together, but on a planetary scale. Enough heat to keep an entire ocean from freezing. Beneath the surface, the structure of Europa begins to take shape. A frozen outer shell of ice, possibly 10 to 30 kilometers thick. Below that, a vast global ocean, and beneath the ocean, a rocky interior. This is important, because where there is rock and water interacting, there is chemistry. And where there is chemistry, there is potential for life. On Earth, life does not require sunlight to exist. Deep in our oceans,
Far below where light can reach, entire ecosystems thrive around hydrothermal vents. These are cracks in the ocean floor where superheated water, rich in minerals, flows out from the planet's interior. Bacteria feed on chemical energy instead of sunlight, and larger organisms depend on them. This is called chemosynthesis, life powered not by light, but by chemistry. Europa may have similar environments. If hydrothermal vents exist on its ocean floor, they could provide heat, energy, and nutrients, everything needed for simple life to emerge. And there are hints that something is happening. In 2012, observations from the Hubble Space Telescope detected what appeared to be massive plumes of water vapor erupting from Europa's surface. These plumes shot material hundreds of kilometers into space. If confirmed, they may be directly connected to the ocean below, which means parts of that hidden ocean are already reaching space naturally. We wouldn't need to drill through kilometers of ice. We could simply fly through the plumes, collect the material, analyze it, search for signs of life. But Europa is not just a place of possibility, it is also a place of extreme danger. Jupiter's magnetic field is the largest and most powerful of any planet in the solar system. It traps high-energy particles from the sun and accelerates them to incredible speeds. Europa orbits within this radiation field. The surface is constantly bombarded by energetic particles. Radiation levels are so intense that an unprotected human would receive a fatal dose in minutes. Even spacecraft have to be carefully designed to survive. Electronics degrade. Systems fail. Time is always limited. And yet, we are going back because the potential reward is too great to ignore. In the coming years, Europa Clipper will arrive in the Jupiter system. This mission represents one of the most advanced attempts to study an ocean world beyond Earth. It will not land. Instead, it will perform dozens of close flybys, scanning the surface with radar, mapping the ice, measuring its thickness, and analyzing its composition. It will search for plumes, and if it finds them, it will fly directly through them, sampling material that may have come from the ocean below. For the first time, we may get a direct look at an alien ocean, not through theory, not through models, but through actual data, actual samples. And if even the simplest form of life is found, everything changes. It would mean that life is not unique to Earth, that it can arise in darkness, in cold, in isolation. It would mean that the universe may be filled with living worlds, hidden beneath ice, beneath oceans, beyond our reach. Europa challenges everything we thought we knew about where life can exist. It forces us to rethink the idea of habitability, not just warm planets close to stars, but cold worlds with hidden oceans. Worlds where life may not just survive, but begin. Right now, Europa remains silent, a frozen sphere orbiting a giant planet, hiding its secrets beneath layers of ice. From a distance, it looks calm, still, lifeless. But beneath that surface, something is moving. An ocean, a system, possibly an ecosystem. We are closer than ever to finding out the truth. Closer at any point in human history. The technology is ready. The missions are underway. The questions are clear. And somewhere, deep beneath kilometers of ice, in a place no human has ever seen, the answer may already exist. Waiting.